There's a pattern of black and white squares sitting in almost every restaurant, every parking meter, every product label on Earth. Most people scan it without a second thought. But this pattern is 32 years old. It was never built for your phone. It was built for a car factory that couldn't keep up with its own parts. By the late 1980s, barcodes were everywhere, but they had a hard ceiling. A standard barcode could hold about 20 characters. That was fine for a can of soup. It was not fine for the automotive industry. Car manufacturers like Toyota were shifting away from mass-producing one identical product towards smaller, more flexible batches of many different parts. Every batch needed to be tracked: supplier, part number, lot, destination. 20 characters wasn't enough room to say all of that. And there was a second problem. Barcodes only read in one direction. On a fast-moving factory line, workers were constantly stopping to physically reorient a label so the scanner's laser could read it in a straight line. That hesitation, multiplied across an entire assembly line, was costing real time. This was Japan in the early 1990s. The country's economic bubble had just collapsed, and Denso, a parts manufacturer inside the Toyota Group, was looking for new ground to stand on. One place they looked was barcode technology, a field they already had experience in, having built barcode scanners since the early 1980s. In 1992, that search turned into a direct assignment. Build something better than the barcode. The assignment landed with an engineer named Masahiro Hara and a two-person team. Hara wasn't chasing a breakthrough moment. He was working through a specific, narrow brief. A code that could be read from any angle, that held roughly 10 times the data of a barcode, and that scanned fast. The often repeated story is that the idea came to him over a lunchtime game of Go. The black and white grid of stones suggested a way to encode information in 2 dimensions instead of 1. Denso Wave itself has referenced the Go board as part of the design's visual inspiration. It's a good story, and it appears to be a real one. But the harder engineering problem wasn't the idea. It was making a grid like that reliably readable by a machine, at speed, even when partly damaged. 2 design choices made the QR code work where earlier 2D codes hadn't. First, the 3 large squares in the corners, the code's eyes. These let a scanner instantly detect the code's position and orientation from any angle at any rotation. Workers no longer had to line anything up by hand. Second, error correction. Using a method called Reed-Solomon coding, a QR code can lose up to roughly a third of its pattern, scratched, smudged, partially torn, and still decode correctly. That's why you can put a logo in the middle of one and it still scans. A code that reads itself, orients itself, and survives damage. That combination is the actual invention, and the reliability behind it is what made it stick. In 1994, Denso Wave released the QR code. But the more consequential thing that happened that year wasn't the release itself, it was a decision made alongside it. Denso Wave held the patent, and from the very beginning, they chose not to enforce it. That single decision is arguably more important to the QR code's global spread than anything about its engineering. Competing 2D codes at the time carried licensing fees. Companies that adopted them stayed inside walled gardens. The QR code, free to implement and openly standardized, first in Japan and then internationally through the ISO by the year 2000, became the format everyone converged on. Quietly, for most of the following decade, almost entirely inside factories and logistics, invisible to the public. For most of its life, the QR code stayed exactly where it was born, inside industrial supply chains. The thing that finally moved it into your pocket wasn't a redesign, it was a permissions change. For years, scanning a QR code required downloading a separate app. In 2017, Apple's iOS 11 added native QR scanning directly to the iPhone camera. That removed the single biggest piece of friction between a code existing and a person actually using it. No download, no setup, just point and look. Even then, adoption in the West stayed modest for a few more years. What made QR codes unavoidable was 2020. Contactless restaurant menus, event check-ins, vaccine and testing records during the pandemic. A code that had spent 26 years quietly organizing car parts became, almost overnight, the fastest way to hand someone information without touching anything. Today, a QR code sits on your parking receipt, your boarding pass, your medicine bottle, a gallery placard, a gravestone. It's on the table in front of you right now, if you're anywhere near a restaurant. None of that was the plan in 1992. The plan was to help workers on a Toyota parts line stop squinting at misangled barcodes. Everything since has been the accidental second life of a solution built for a completely different problem. Masahiro Hara still works in the field he helped create. In a 2020 interview with The Guardian, he reflected on the code's total lack of licensing income with a kind of dry humor. "We don't receive a commission each time it's used." He wasn't complaining. That absence of a toll gate is exactly why 2 billion phones can read his invention today. The most used piece of technology in your daily life probably wasn't built for you at all. It was built for someone else's problem, decades before yours existed, and it waited. The QR code didn't go viral. It waited 30 years for the rest of the world to catch up to a decision made on a factory floor in 1994.